Understand how the mass percent of an element is calculated. The mass percent of chlorine in any chloride salt is determined by the ratio of the molar mass of chlorine to the total molar mass of the compound. Mass percent of Cl equals molar mass of Cl over molar mass of compound times 100%. Analyze the effect of impurities on mass percent. Pure NaCl is 61% chlorine by mass. The analyzed sample has a chlorine mass percent of 75%. For an impurity to increase the overall mass percentage of chlorine above the baseline of 61%, the impuring substance must contain a higher mass percent of chlorine than pure NaCl, greater than 61%. Compare the potential impurities by examining cation molar masses. Since we are comparing binary salts with a 1-to-1 stoichiometric ratio of cation to chloride and ion, Cl approximately 35.5 grams per mole, the mass percent of chlorine is inversely related to the molar mass of the cation. Text molar mass of cations. Li to the power plus 6.94 grams per mole, less than Na to the power plus 22.99 grams per mole, less than K to the power plus 39.10 grams per mole. A lighter cation means a smaller total molar mass of the compound, which yields a higher percentage of chlorine by mass. A heavier cation means a larger total molar mass of the compound, which yields a lower percentage of chlorine by mass. Calculate/estimate the chlorine mass percent of the options. For LiCl, since lithium is significantly lighter than sodium, the total molar mass of LiCl is much lower, approximately 42.4 grams per mole. Its chlorine mass percentage is mass percent of Cl in LiCl equals 35.5 grams per mole over 42.4 grams per mole times 100%, approximately 84%, because 84% greater than 61%. Mixing any amount of LiCl with NaCl will pull the average chlorine mass percent upward. A mixture of the two can logically result in an overall value of 75% chlorine by mass. Conclude. The presence of LiCl is the only scenario consistent with raising the mass percent of chlorine to 75%, confirming option D as the correct answer. The correct answer is option D. The sample contains NaCl and LiCl.